Hello and good day. Welcome back to our class. This is teacher Onin de Guzman and our topic for today is illustrating an arithmetic sequence for grade 10 quarter 1. Let us recall that a sequence is an arrangement of objects, numbers, or even figures which follows a certain pattern. Also, you have learned about the processes and finding patterns of any sequence. So that's why a sequence in which term after the first is formed by adding a fixed number to the preceding terms is called arithmetic sequence. The fixed number or constant is called the common difference denoted by the symbol D. To illustrate the arithmetic sequence, let's consider problem number 1. Determine if the sequence is arithmetic or not. If it is, find the common difference and the next three terms of the sequence of -4, 3, 10, and 17. Let's recall that a sub 1 or the first term is equal to -4, the second term is equal to 3, the third term is equal to 10, and the fourth term is equal to 17. And let's recall also to get the difference, that is, we will subtract the next two consecutive terms. So that is why a sub 2 minus a sub 1, so that is 3 minus -4 is equal to 7. Similarly, a sub 3 minus a sub 2 is equal to 10 minus 3 equals 7, as well as a sub 4 minus a sub 3 is equal to 17 minus 10 is equal to 7. Since there is a common difference between consecutive terms, then the sequence is arithmetic. Let's move on to the second part. So that is why we would like to find the next three terms. So we will move on to the fifth term. So that is a sub 4 plus 7 is equal to 17 plus 7 is equal to 24. While a sub 6 is equal to a sub 5, or the fifth term plus 7 is equal to 31, and the seventh term is equal to 31 plus 7 is equal to 38. So therefore, we can say that the next three terms are 24, 31, and 38. Let's move on to problem number 2. Write the first five terms of the arithmetic sequence with 5 as the first term and with a common difference of -2. So recall that the first term, that is equal to a sub 1, is equal to 5, while the second term, that is the addition of a sub 2, which is equal to the first term, plus -2, which is the same as 3. Third term is a sub 3 is equal to a sub 2 plus -2, which is equal to 1. Next one, the fourth term is equal to the third term plus -2. We have -1. Okay? And finally, the fifth term, that is equal to the fourth term plus -2. We have -3. So therefore, the first five terms of the sequence are 5, 3, 1, -1, and -3. Let's consider problem number 3. Find the common difference of an arithmetic sequence whose second term is equal to 1 and the fifth term is equal to 7. Let's recall that the third term is equal to your second term plus common difference. So this is our equation number 1. While our fourth term, that is the third term plus the common difference, which is equation number 2. And the fifth term is equal to the fourth term plus common difference. This is our equation number 3. Having said with that, so I'll start with the fourth term is equal to the third term plus the common difference. But I can substitute now the value of the third term, which is the second term plus the common difference, plus d. Okay, I simply substitute that. Now, working on with that, I have second term plus 2d. So this is my fourth equation as the fourth term. Next, I would like to work on with my fifth term. So we have a sub 4 plus d, or the fourth term plus the common difference. Substitute the value of your fourth term. So we have here a sub 2 plus d. So a sub 4 is equal to a sub 2 plus 2d. Substitute that. Then I can have now the equation 5 as the fifth term is equal to the second term plus 3d. Next, since I know that the fifth term is equal to the second term plus 3d, based from our given, your fifth term is equal to 7. Substitute, then working on to isolate the value of d, I have 7 minus 1 is equal to 6, which is equal to 3d. Then divide both sides of the equation by 3, so the value of d is equal to 2. So therefore, I can say that the common difference is equal to 2. Let's move on to problem number 4. Find the common difference of the arithmetic sequence 3a minus 1, comma, 3a, as well as 3a plus 1, and so on and so forth. Notice that your first term is equal to your 3a minus 1, while a sub 2, or the second term, is equal to 3a. Then, the third term is equal to 3a plus 1. Now, let's recall also that the common difference is equal to the difference of the two consecutive terms. So if I have the second term minus the first term, so this is my equation number 1. Or I can say that the common difference is equal to the third term minus your second term. So I can use this one as my second equation. Now, I can say that d, or the common difference, is equal to your second term minus your first term. So therefore, since my second term is equal to 3a minus my first term is 3a minus 1. So I have here d is equal to 3a minus 3a. Then, since I distribute negative, so the negative 1 will become positive 1. So d is equal to 1. So therefore, I can say that the common difference d is equal to 1. Let's consider the fifth problem. Find the value of a to make 3a plus 1, comma, 4a, 6a plus 1, and so on an arithmetic sequence. Let's recall that the first term is equal to 3a plus 1, while the second term is equal to 4a, and the third term is equal to 6a plus 1. And recall also that the common difference is equal to the difference of two consecutive terms. So that is why if I'll use a sub 2 minus a sub 1, this is my first equation, or d is equal to the third term minus the second term. So I can use this one as my second equation. Notice that if I use a sub 2 minus a sub 1, this is the same also as a sub 3 minus a sub 2. By simply substituting the value of a sub 2, a sub 1, a sub 3, and a sub 2, I'll come up with 4a minus 3a plus 1 is the same as 6a plus 1 minus 4a. So by manipulating this, so I'll come up with 4a minus 3a minus 1. On the right-hand side, I have 6a plus 1 minus 4a. Simplifying it further, I have 4a minus 3a. That will result to a minus 1. On the right side, I have 2a because 6a minus 4a is equal to 2a plus 1. Then, to simplify it further, so I have here a is the same as negative 2. So therefore, the value of a is equal to negative 2. Let's move on to real application of this arithmetic sequence. Let's have number 6. I was advised by my physician to walk each day in the morning as my daily exercise. On my first day, I walk 40 meters. On the second and third day, I walk 60 and 80 meters respectively, and so on. Which of the following is the distance I walk on the third day if I continue the pattern in my daily walk? So let's recall that on the first day, you walk 40. On the second, you have 60. On the third day, you have 80. If we will continue this, my fourth is 100 meters, fifth is 120. So there is an increment of 20 meters each day. So continue it further, I have 114, then I have 160, then 180, 200, and on the third 10 or on the 10th term, I have 220 meters. So therefore, in the 10th day, the distance I traveled is 220 meters. So that ends our discussion on illustrating arithmetic sequence. Again, this is Teacher Onin Guzman. Do not forget to subscribe to my channel so that you will be notified about my new videos. Thank you.